So let's look at creating a graph from a function. So we have this polynomial function here, and we want to create the graph of this function. Now the first thing to note is that we need to find one of the roots of this function. Now we can get the roots from this value here. Now the example here is quite simple because the only factors of 1 are the values of 1 and minus 1. So we can try the value of 1 first of all and see whether that is actually a root of this function. So we can say that if x equals 1 is a root, then x minus 1 will be a factor. Now we've seen this in our previous examples that if we had, say, that value there had been 15, then we would have had to have tried the values of, say, 3 plus and minus 3 plus and minus 5 plus minus 1 plus minus 15. So all of the factors of the value of 15 would have to have been tried in order to try and find out what the actual factor of this polynomial is. But this example here, we've only got a value of 1, so it's quite straightforward. So now let's start off with try to find the y-intercept. So it cuts the y-axis whenever this function is equal, x is equal to 0. So whenever x is 0, well, you're just going to have this will be 0, that will be 0, that will be 0, and we'll have a value of 1. So it must cut the y-axis at the point 0, 1. So we've got 1 point. Now let's look at where it cuts the x-axis. So these are the x-intercept points, and that's going to cut the x-axis whenever the value of y equals 0. So these are the roots that we're looking for, and we can use synthetic division. So let's do the synthetic division on this, and we're assuming, as we're saying up here, that the value of one of the roots is x equals 1, and we're just testing that out. Now we could have tried minus 1, but I know the value of 1 works, so we're going to put this one in, okay? So we'll start off with the polynomial. So we'll have the coefficients will be 4, minus 1, minus 4, and 1. And we've got our root here, which is 1. So we start off with 4. We say 1 times 4 is 4. We add them together, we get 3. 1 times 3 is 3. We add them together, we get minus 1. 1 times minus 1 is minus 1. We add them together, we get a value of 0. So the remainder is 0. So that value 1 must be a root of the polynomial, and x minus 1 must be one of the factors. And you can see here that if x minus 1 is one of the factors, the other factor is going to be given by these values here. So it's going to be 4x squared plus 3x minus 1. So that's the other factor. And you can see when you multiply these together, you get the minus 1 times minus 1 will give you the plus 1 here. So that's just a little check. Now what we can do is we can separate this out as well. So that's going to separate out into 4x minus 1, x plus 1. Now don't worry too much if you can't see how that gets separated so easily there. We will go over it when we go over the quadratic section next. So we're going to have these three factors, x minus 1, 4x minus 1 and x plus 1. So it means that the roots here are the values of 1, 1 upon 4 and minus 1. So that's where it cuts the x-axis. So it means we've got 4 points. Now we've got our 0, 1 here from our y-intercept, and we've got our 3 roots, which are minus 1, 0, 1 upon 4, 0 and 1, 0. So let's move on and we'll look at finding the turning points of this polynomial using a little bit of the differentiation. So we're going to use calculus, and we're going to use the differentiation in order to find the turning points. Now we know we get a turning point when f derived of x is equal to 0. So we just differentiate our polynomial. So we'll go back up and have a look at it. So when we differentiate that, it's going to be 4 3s are 12, so it'll be 12x squared minus 2x minus 4. And we've got that here. And whenever that is equal to 0, we know we've got a turning point. So we can take out a common factor of 2 here, so we're left with 6x squared minus x minus 2 is equal to 0. And then we can factor this. Again, this is another factorisation, which we'll go over in the quadratic section. So that's going to give us 3x minus 2 and 2x plus 1. You can see that as well. When you multiply that, you're going to have 6x squared, so that times that. You're going to have 3x there, and you're going to have minus 4x. So 3x minus 4x will give you the minus x. Minus 2 times 1 is minus 2. So it means that the turning points must occur at x is equal to 2 upon 3 and x is equal to minus a half. So whenever x is equal to 2 upon 3, the y value of this is going to be, well, you just put the 2 upon 3 back into the original equation. So the original equation, y is equal 4 times x cubed, where x is now 2 upon 3 cubed, minus 2 upon 3 squared, minus 4 times 2 upon 3 minus 1. And that gives a value of minus 0.926. And whenever x is equal to minus a half, the same thing occurs. We put minus a half in for x, and we get the value of 2.25. So we're just putting the values of 2 upon 3 and minus a half back into the original equation up here. So let's continue on to the last page and we'll see what the graph looks like, and we'll also find out what the nature of these turning points are. So we've taken a note of all our points here, our 0, 1, which where it cuts the y-axis. We've got our roots at minus 1, 0, 1 upon 4, 0 and 1, 0. And we've also got our turning point, so that's one of the turning points there, and that's the other one. So we can make this little table up. So we can take our points, which are our turning points, which are going to be at a value of minus a half. That's one there, and 2 upon 3, which is that one there. So we know that the derivative at this point is 0, so it's going to be flat. So what we'll do is we'll look and see what happens whenever we get a number that's even smaller. So if we take, for example, minus 1, and we put the minus 1 into the f derivative of x, so we're putting minus 1 back into the f derivative of x, which is this here. So we put minus 1 in here and we see whether the derivative is a positive or a negative value. So when we put that in, we get the value of f derivative of x is going to be positive for minus 1. For that value 0 it will be minus, for this value of 1 it will be positive again. So it means that we're going to get a slope that's going to go up the way, along, down, along and then up. So taking all of these points and the nature of the turning point, you can see that the graph is going to look like this. It's going to come up here, it's going to hit the turning point here, and it's going to come down past this y-axis at this point, back down through the x-axis at this route here, and then the turning point, and then this route here. So you can see the three routes, this one, and this one. So finally, let's go ahead and we'll put this into the graphical calculator and we'll see whether we do actually get this curve. Okay. So let's type in the function and see whether we actually get the graph that we are expecting. So we'll say f of x is equal to 4x cubed minus x squared minus 4x, and it's plus 1. Okay, so it looks like it's in the right shape, it's heading up and down like this. So let's check the points. So we've got minus 1, 0 is one of the roots, 0.250 is the other root, and 1, 0 is the final root. So those are the three roots that we worked out. The point it crosses the y-axis is along 0 up 1, and the turning point is minus a half, 2.25, and the other turning point is 2/3, so that's 0.667, minus 0.926. So it's all worked out as we expected it to, and this is the graph of our polynomial function. So thank you for listening. I'll get you in the next video. Goodbye.